Hey, short little video today on event sourcing in Python and HTML. So, what's event sourcing and what's its use case? Event sourcing is part of a larger server-side events library, set of protocols. Depending on your language implementation, it's broken into different libraries. For Python, most of the use cases are subsumed into FastAPI and one or more things. By the way, you don't have to use FastAPI. I'm using it in this example. Out in the real world, FastAPI is probably the most prevalent of the server construction for HTTP and related protocols. It's stable. A lot of Python developers learn it and know it. It's very fast. It scales well. It has all of the required hooks to do proper 12-factor development. It's very stable. So it's very attractive. So if you're doing this sort of thing professionally, I recommend FastAPI very strongly. But that's not to say there aren't other things that are also good. So our problem statement is we have a server that's spitting out a series of events. We need to consume them unidirectionally. We want to do it really simply. Different use cases for this in my life. I wrote some dashboards for some lab software. And so there were hardware running in the background that were testing lab samples. They were doing, they had the status of where they were. Some of these things were really long running. I wanted a dashboard that sort of showed in sort of semi-real time what the status of all these different things were. The other thing, I've used it a lot in financial systems to implement things like tickers, where we're showing, the values of stocks that are changing. Depending on the sensitivity, this protocol may still have too much latency, oddly, but we were doing it worked pretty well. Been around a long time. It's really stable. And for almost all browsers these days support it. HTML5 compatibility is sort of required, but that's not such a big deal. So, most modern smartphones, almost every browser on Earth supports this. You can go to browsercompatibility.org and you can go look to see if your browser does, although I'd be shocked if this didn't work for you. I've got a source. I want to just spew out messages to anybody who cares to listen. So I expose an API endpoint, spews out the messages, and then I have any number of consumers that are listening to them. And that's kind of my use case. The thing that would pop into most people's heads is, well, I've heard a lot about WebSockets. When do I want to use a WebSocket versus event sourcing? And here's kind of the handy dandy chart. WebSockets are two-way. WebSockets are heavier in terms of code and sort of infrastructure complexity, but they offer two-way communication and they allow the exchange of binary data. If you can get your data that you want to send to your clients, and the clients can be anything that can essentially subscribe to HTTP, and so I've got a JavaScript example and a curl example for you, then fine, lovely. WebSockets support binary, and they support complex data types, anything that Ajax fundamentally supports, which means they support anything that is a data type in JavaScript that is serializable, that has a serializer. And in theory, non-serializable types, if you write custom serializers and deserializers for your client, are supported, right? The client and the server just have to agree on what the serialization format is, or it doesn't work. Event sourcing basically says everything's a string. But again, there has to be an understanding on the client's part about, what this thing is going to return. And event sourcing fundamentally returns a set of name value pairs that are strings, string. So you could, in theory, return JSON as long as, it's string JSON and the JSON is stringified. And there are quirks about that, but you could make that work. And as you'll see when we get to the code, the coding is really very easy. I'll do another video on WebSockets and show you some of those things. The other thing that you have to understand, and we'll get into that when we look at the code, is that WebSockets has sort of built into it the support for some of the things like cross-origin restrictions and things like that. When you're working with event sourcing, you have to add a couple extra lines of code to deal with that, and we'll take a look at that. Auth mechanisms and things like that are much more sophisticated in WebSockets because they have to be, because since WebSockets allow you to send things to the server, you want that level of sophistication. So the other thing about WebSockets is the client opens a connection to the server and it stays open. So if you have 1,000 clients, then you're going to have 1,000 connections on your web server that are all keep alive and are caching no. And we'll see that as well. So there are things to think about. But for tactical use, like in the lab, they're pretty good. And if you have the ability to scale horizontally, event sourcing works pretty well for things like tickers and things. We had on our system, we were able to load test to north of 100,000 current connections. So here's where you can find the source. Let's start server side with some very easy but fairly nuanced Python. So we used UV, we created a project, we added FastAPI and async IO to it. When we installed FastAPI, we used the option to sort of install everything. You would probably use the more nuanced approach in a real project to install only what you need. We're going to create an app using the FastAPI constructor. We're going to add CORS middleware. Why? Because this connection methodology, event sourcing, requires it on modern browsers or modern clients. You will get, if you omit this or you get it wrong, you will get a CORS error. Frequently, that error will be swallowed by your stack. It's particularly the case in the browser. So if you have a situation where you've got a page and it's just not showing what you expect it to show, hit the F12 button, go into your browser debugger and take a look and see if you're getting an error, a JavaScript error. And I would bet you that one of the JavaScript errors you could be getting, if it isn't syntax related, is probably because your middleware is configured incorrectly. And if you do not require auth, or even if you do, the place to start debugging your connection issues is CORS. So in this case, I did a very bad thing, TM, and that is I said, just allow every kind of connection from everywhere on the planet. You'll probably want that to be a lot more nuanced in your solution. Additionally, you will probably want all of the argument to add middleware to come from configuration and not be hard-coded like this. But for the sake of a simple demo, I'm just hard-coding it. But please, please don't do this for real software. Now we have FastAPI with the appropriate CORS middleware set up so that clients can actually connect to it. We have no credentials, although we set allow credentials to be true, because if they were trying to connect with credentials and we had it set equal to false, it would see the auth header and fail to connect, which sounds counterintuitive, but on a lot of connection clients, that's the way that would work. So let's just go down and take a look at the meat and potatoes of it, which is pretty simple. We have an asynchronous function that generates an infinite series of messages. The messages, as we said before, have to be strings. Under the covers, you'll notice that very subtly, they're dictionaries. That is the key. Here's our separator, the colon. And then here is the value part of the string. The format is very fussy. The space after the colon turns out to be important, as does two carriage returns. Understand that you can have a lot if you're doing this in a different programming language, right, you can have a lot of fun with client connection issues or client connect, but you get garbage messages because the client is interpreting the message string incorrectly because you have formatted using the wrong character. It is incredibly fussy. The key has to be lowercase. Typically, the key has to be data : space, and it has to be terminated by not one but two carriage return characters. It's part of the protocol. To avoid using all the CPU time on planet Earth, after the yield, we're sleeping for a second. Notice that it is asynchronous. And the endpoint, which then calls that, which we'll dissect in detail in a minute, is asynchronous too. Which brings me to my second observation about writing event sources in Python or pretty much any other programming language, C#, Java, whatever. If it's asynchronous, which it should be, it needs to be asynchronous all the way down. So if you have a situation where you're going against database or some other external data source, you want to make sure that all your access methods are asynchronous and that you're doing the asynchronous part of the development correct and that it's executing correctly long before you ever write an endpoint for it. And you really should probably write some unit tests, which I did not do here, bad steward, to make sure that the asynchronicity part is correct. Notice in Python, the use of the word yield to return things from our asynchronous method and the use of await to execute the sleep function correctly. If you omit the yield or the await, if you use return instead of yield, it will not act correctly. If you omit the await on sleep, you'll probably get an error, but even if you got it to run, it would not run correctly. So there are a bunch of nuances. Additionally, if you have something that is the root of the generator and your messages are not always available. If you're only going against, say, a database and you're only looking for things that have happened since the last time you checked, for example, then you should make sure that you yield nothing. And there are some notes in the Python documentation for FastAPI about that are worth doing. And some pros and cons of where to put that. If you do it like I have done it here, then there is no opportunity to deal with there being no message available, right? There's always a message available in my use case here. But if there's a possibility that there's no message available, then you need to be able to deal with that. And specifically, you need to make sure that your return doesn't return a streaming response. It returns the no data response, and that your client is okay with that, and that you document all those things. So one of the great things about FastAPI is that it will generate documentation from your annotations. And so you should, if that's and there's a possibility of a no data response, then you need to add that annotation so that it's added to your documentation so that your client consumers will know that that's a possibility. In this case, this always has a message to consume. Notice also that the media type is very fussy and very specific and very lowercase. I had a problem where I was genning up another client for a project, and it turned out that the client library was super fussy about the case of the content type, which it's not supposed to be because that's outside the standard. But just so you know, that's a possible thing. Okay, so here's Start Server, and it's going to start our favorite FastAPI kind of development environment. It's running on port 8080, which is where I configured it to run. You can look at the details here in startserver.PowerShell. Pretty standard UV command. I love UV. If you're a Python developer and you're not using UV, I have but one question. Why? Okay, that was many questions, but you get the idea. Use UV. It is your friend. Let's switch windows and do a curl. And you can see that a single curl command is returning our stream. Let's take a look at the curl script. Again, we're just doing a curl on the endpoint, localhost 8080/stream. Curl understands that when the protocol comes back with the content header, right, that it's going to sit and wait for a stream of things to come back, because curl is very clever. Okay, let's go and do something a little bit more real world and look at an HTML page, pure HTML, slightly fancy because this is my standard template based on Bootstrap that has all my favorite toys in it. And for whatever reason, my VS Code has two different linters fighting with each other. One wants stock type to be capitalized, one wants it to be lowercase, one wants terminating tags, one doesn't. So whenever I make a correction, it corrects it back. It's very annoying. But here's the main guts of what we care about. We have our URL, which, as you saw from the curl command, is 8080/stream. We, on the load event, because we want to make sure our page is fully rendered, we go get the URL element that's displaying the URL, and we set the text content. Then we go get the result element, which is that div. And then we say, okay, well, if the event source type is available, if your browser supports event source, then do event sourcey stuff, else say sorry. The sorry part, again, should never happen on modern browsers. We create a new event source just by giving it the URL. We'd have to do probably some more things if it required auth. Those things you can read about in the event source documentation. And we say, okay, well, whenever we get a message, source.onMessage, I want you to execute this event. And in this case, we're going to take the contents of my div, and we're going to take whatever is in the div now, right? Plus equals, and grab the event data, which is always going to be a string. We're going to add a line break to it and display it. Browser will update the view to show the event data. Server's running in the background. We'll run it with live server, and you can see there is our events. And that's it. It's not that tricky. If you add auth, it's a little more tricky, but it's not that much more tricky. And again, this scales pretty well. It's super easy, and you can do a lot of really clever things with it. Thank you for your kind attention.